Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, Computer Science and IT. Myself, Mallesham, Devasane. In this session, we are looking at the closure properties for a set of regular languages, along with the important words like closure, which is closed or not closed. Any property that we are going to talk about is clearly explained in this class. Yes. So before starting the session, let's look at what we have learned in the previous session is about the identifying regular languages. As you know that identifying regular languages will become easy if you are able to understand the representation of the problem, and if you have an idea of writing expression or constructing finite data or writing regular grammars. So if you have the concept on those topics, identifying regulars will become easy. Now in this session, the closure properties, if you want to understand whether they are closed or not for a given domain, then you must be good at understanding what we are looking at, what domain you are looking at, and what operation you are talking about. So two words are mainly this special session is going to depend on two things. One is the domain and another one is operation. So let's, without wasting our time, let me introduce myself. Yeah. Myself, Mallesham Devasane. I have secured all day rank 119 and 210, and I have secured these two ranks during my BTech in third year and final year. Then I have completed MTech from IIT Bombay, and I have 12 years of teaching experience. Here I am going to take TOC compiler programming, and this is my referral code which will help you to get the subscription on Unacademy with 10% discount. So once you come to the Unacademy, then you can attend any lecture from any educator. That is a most beneficial plan for you guys. The plan is that you choose 1 or 1.5 year or 2 years, you will get more benefited from Unacademy if you have the time. If you are joining late, then 6 months, even 3 months also sufficient. But when you have the time, never choose the plan 1 month, 3 months, because you can't complete the 12 subjects in depth. That means you need to have a practice, you need to learn every topic clearly. So then it is recommended to go for the 1 year or 2 years or 1.5 year plans. All right, Nishu, good evening. And what we are talking about here, the benefits are here: live classes, crash courses, and long-term batch, short-term batch, and so many batches. Every batch you can attend. There is no restriction which batch you are going to attend. Any batch or all the batches you can attend as your choice. But we always recommend to go and plan well and systematically you prepare. Even though everything is free inside Unacademy, don't waste your time. So that is the reason we have also started iconic subscription plan. What is the benefit of this? If you are not able to understand which course from which educators and how to prepare, this is we are going to help you how to plan well, and you will have a study planner, you will have a coach to guide you all the time, you will have separate sessions, and you will have personalized analysis and separate study material. So these are the advantages of iconic. Yeah. And I have, these are about my classes, but if you are going to look at Unacademy, thousands of classes are available freely on Unacademy. But as you know that, looking at each session separately, which will be very difficult to prepare entire syllabus. So even though you have practice classes, revision classes, and previous year gate questions, so many classes are there, but identifying them and preparing them, which is going to take much time. So please, if you want to learn on your own, you can visit unacademy.com/devagate.csc. All the classes are completely free. But if you want to join Unacademy Plus, which is structured courses, and you will have a complete course for every subject, like I'm teaching TOC compiler C programming, other people, so many educators are there who are going to teach remaining other subjects. You can attend any class from any educator, and these are my courses that I am taking on Unacademy, and soon I'm going to start the another course on TOC. Okay, what are the benefits of the Plus and Iconic? Just now I told all the benefits of Plus are also applicable to Iconic, and Iconic is a plan which is going to be superset for Plus. Here you will have additionally dedicated coach and personal live interaction with educators and separate study material and so many other benefits for Iconic subscribed peoples. And if you look at the Plus, and these are three popular plans: 1.5 year, 2 years. What is the price for that? After applying referral code DEVALIVE, and 27 to 25 for 1 year, 34,650 for 1.5 year, and 39,600 for 2 years. And similarly, you have iconic plan, which is for 1 year and 2 years. Apply DEVALIVE to see the total price 40,500 and 54,000 for 2 years. Yeah. Shubhastri, good evening. All right. Okay, good. Let's begin. These are the videos and these are the classes from many educators where you can learn maximum required content from us on this channel. Please also attend other classes including mine, and all the subjects are going to be covered at one platform, that is Unacademy Computer Science. Okay. Yeah. I hope we are ready to start now. And obviously, if you are going to watch any movie, obviously you will see the names, right? So you can't see that you can skip, right? This is, if it is you are watching offline video, you can make it forward. But if you are coming to the live, if you are going to any cinema theater, you must look at the names. If you are interested, listen to, watch them. If you are not interested, talk with other people. Amit, it is yeah, Amit, I have seen you first time on this platform. If you are interested or not, that please don't comment anything if you don't like it, right? So we are here to help you anytime. And you ask the doubts from the subject, but please, you can't tell something which is beyond your control. Come on. If you are teaching freely, that means even we want to get popular, right? Even though we are very popular, but most of the people do not aware of these classes that we are running on this platform. It is your responsibility if you are attending. And you come once in a while and you dislike, that's okay, fine. But we are here, we are there always here to teach and to help the students, right? Fine. In previous session, we have learned regular expressions, finite automata, and regular grammars. And also in the last class, we have seen how to identify regulars and non-regulars. Clear? These are the previous sessions I have completed. And in this session, our target is to complete the closure properties for mainly regular languages. But can you understand directly for regular, which is very difficult for you without understanding the definition of what is closed and what is not closed. And you should also understand for finite languages what are the closure properties that we can understand, and for infinite languages, and also after knowing about regulars, then you can also apply for non-regulars. So this is most important for you. Okay. All right. So let's begin this chapter with what is closure. And people talk about closed and not closed. There is no word may not be closed. Remember, the two words only there, closed or not closed. What is the meaning of closed and what is the meaning of not closed? Yeah. Yes. Amit, 1 year package, why will not work? Even 1 month package also works. But do you have the capability to complete the 12 subjects? Obviously, 1 year is more than sufficient if you are aiming for the next year, 2022. And if you want till Feb, then obviously 1 year you take, and later on you can extend for 1 or 2, 3 months. That depends on you, right? But we are there to help you. If you have any doubt, we are always there to help you, whether it is subject or whether it is subscription or whether it is you require a guidance how to prepare. We are always there to help you, and you only asking these doubts, and everybody will have the doubts. And that is the reason we always talk about how to subscribe, whether it is plus or iconic. This is very important. Those people who are seriously preparing, and definitely YouTube classes will help you for self-motivated people, right? If you are not motivated, how can you watch the video for a certain time without having live interaction? All right. Now, what is closure? Guys, there are 2 points. One should be a domain, and you should know which domain you are looking at. Another one is you should know which operation you are applying for. If you are not worried about these 2 points, then there is no definition of closed, not closed. Remember, the closed is We are talking about operation, but we are applying on domain. So there should be a domain. Let's say this is a domain. In this domain, here always we take infinite number of elements. But if you have finite number of elements, that's a particular problem. That's okay. Here we have the elements like languages, like regular languages. Sometimes we talk about, and non-regular. Sometimes we talk about what is your domain. D could be, this is your D. This is your D. Set of finite languages. This is your D. You decide which D you are talking about. Are you talking about for finite languages? D basically is a set of finite languages, or set of infinite, set of regulars, or set of non-regular. You decide before applying the operation what is your domain. Second, and what operation you are going to think about, because operation you are applying for languages, right? So it is a set like union, intersection, difference, complement. So many operations are there in the world. Hundreds, thousands. So many operations are there in the world. So which operation you are going to apply? I'm just using the name like a star. Star can be union, or star can be intersection, star can be difference, some operation. So when you're talking about a closed word, you have to say something like this. Star is an operation, right? Is closed for D, the domain D. It means the domain D is closed under star. This is how we speak the particular domain and operation. How do you speak about closed? So then what is closed? I'm not talking about what is closed so far. How do you speak closed word? Alright, Shubhasri, you can ask at the end. Star is closed for domain D. There is certain operation is closed for domain D. What is the meaning of this? What is the meaning of this? If and only if for all, I can say x comma y or L1 comma L2, it's your choice. For all xy belongs to D, such that x star y must belongs to D. This is your definition of closed. Then we say the star is closed for domain D. When we say every two, xy can be same or different, we don't care, but every two elements, that means every two languages, when we apply that operation, the result is also inside the domain. Then we say it is closed. Example, let's say talking about finite languages. Union is an operation. This is the star, and D is a set of finite languages. Set of finite languages, like sets. Set of finite sets. Now if I apply union, is it union closed for that set of finite languages? Set of finite sets? Yes. Take finite set and take another finite set, do the union, you always get a finite. That means it is closed. You can say it's closed. Union is closed. And that is how you talk about the operation and domain. Union is closed for the finite languages or for set of finite languages. Everybody clear this point? Come on guys. Closed. If I ask, is that addition closed for the natural numbers? How do you think about it? Okay, natural numbers, set of natural numbers is my domain. If you pick any two natural numbers, do the addition, result is always another natural. So that means addition is closed for naturals, right? And if I talk about the difference, the subtraction I'm talking about. Difference, is it closed for natural numbers? Set of natural numbers. If you take 2 and 3, which are belongs to n, and 2 minus 3 is a -1, but -1 is not in the natural set, then if anybody is saying that star is not closed for domain D, how do you say that? There exists, now you don't say for all. There are two elements, because the binary operation I'm talking about. Unary, you just take one. There exist two elements, that means two languages or two numbers, whatever it is, depends on your domain, such that the result is not inside the domain. Example, if I do finite languages, if I take finite languages, if I take the complement, if I take the star is complement, and domain I am taking the same, finite languages only, set of finite sets. Now if is this a unary operator? Remember, it's not a binary. Now take only one input, that is one language from the domain. Complement of finite, guys, it is not finite at all, because here we apply over sigma. It's not a mathematical topic, guys. It is a theory of computation. The complement of a finite is infinite in TOC. Infinite. We are not talking about regular. Where I use Shubhasri? I am not talking about regular, non-regular. I am talking about finite languages. Think about finite languages first. Later on regular, depends on the options. Now I am talking about finite languages. I have taken a finite language. I do the complement. Result is never be finite again, because complement of a finite is infinite in TOC. So there is any example you take, it works now. Any example. This we say not closed at all. Not closed. Example, natural set. Just now I explained. Difference. 3 minus 2 is there inside, but 2 minus 3 is not inside. 2 is inside, 3 is inside, but 2 minus 3 is outside the domain. So at least one example in the domain. When you pick that elements, when you apply the operation, at least one example goes outside the domain. That we say it is not closed. Anyhow, we have to understand this is a beginning, right? So anybody saying, and there is no word may not be closed. Only two words. Either answer is closed or answer is not closed. But before that, fix your domain, fix your operation. Right? Fix your domain. Yeah. Now, I'm going to talk about that. What are the closure properties? We are saying closure properties. What are closure properties? Union is a property. Intersection, complement, difference, concatenation. These are the properties. Are they closed or not? That we have to decide. Is it closed or not? How do you know it? That depends on your domain. Closed or not closed, that depends on domain. That depends on what domain you're talking about. Everybody, whether it is closed or not closed, that depends on domain. These are the closure properties, guys. Each one is closed or not closed. We are going to talk about that depends on domain. Union may be closed, may not be closed. The domain will decide, right? Two things you have to remember. Closure property, nothing but operations or properties basically here. They are functions, they are mappings, but they are going to talk about the property of languages. Okay, now let's start. To understand such operations, we will look at it. Suppose closure properties you are applying for finite languages. Now our domain is set of finite languages. Set of finite sets. And in this domain, what do you have? Over some sigma, because we always take the sigma in TOC, and it is a finite language. Every element is a finite language. Remember, every element is a finite language. How many finite languages are there? Infinite number of finite languages are there over sigma in the domain. Infinite number of finite languages are there over sigma. Is it clear? In this domain, not 5 guys, infinite number of finite languages are there. Now you pick any two, same finite language again, or any two you take. If it is, look at that, union is a binary. That means 2 inputs required. Intersection is binary. Complement is unary, guys. And difference is again binary. And concatenation is binary. Reversal is unary. And clinic closure is also unary. Positive is unary. Subset is also unary. And here there are 2 types of operations. Unary and binary. In some of the programming languages, even ternary operators also there. Here also we have, n array also. Okay, now let's try to focus on this. Great. Now we have to understand how to say that it is closed or not closed. Now we understood our domain is finite languages. Union, is it closed? Is it closed? Closed for which languages we are talking about? Finite languages. Why it's closed for finite languages? Because finite union finite is always finite. Any 2 finite languages you take, it's always finite. Is it clear? For all fi comma fj, any ij doesn't matter, that when you apply that fi union fj, you will get some fk. This is always true when you take. It's not there exists fi fj, guys. For all fi fj, the fi union fj is always fk. That fk is one of the element in the same domain. Yes, that is the reason closed. Everybody? Okay, closed. Because finite union finite is hamesha finite. And intersection is also closed, guys. Same point. For all Fi and Fj, Fi intersection Fj. Is it some Fk or not? Yes. Finite intersection finite is always finite. That is the reason closed. And never change your mind to regular, infinite, these things. Your domain is fixed. Domain is fixed. And complement, guys. Complement, if you want to do any complement here, Fi complement, sigma star minus Fi. And sigma star is infinite. And minus you are doing finite. Hamesha infinity only, guys. You take any finite language, its complement is outside. Now we don't want every finite. Just can you show at least one finite? Yes. Any finite you take, it is already outside the domain. So we say not closed. Why we are saying not closed? Because I can show you at least one finite language. Its complement is outside the domain of finite languages. Yeah. So it's not closed. Not closed is not going to depend on every element. Remember, it's going to depend on at least one element of the domain. Here, one language you show that. Example, I'm showing you. L is equal to, let's say, epsilon. It's a finite language. But when I do L complement is sigma plus. That's enough. This is infinite. That means if you take the complement of the epsilon, it's going to be infinite. It's outside the domain. That's enough. I don't need to show every finite language. Okay, depends on example. Difference. Guys, is that finite minus finite? Is it always finite? It's true. It's true. That's enough to say it's a closed. And concatenation, finite dot finite. Any two finites, result is finite. So closed. Reversal of finite is again finite. So closed. And the clinic closure of finite. Clinic closure of finite. Yeah. That's what, Amit, what you did. You were asked a question, I answered it, and you disliked it. This is not good. Anyhow, clinic closure. What is clinic closure? Clinic closure operation, everybody knows that. If L is equal to epsilon, and what is L star? Epsilon. And if L is equal to just A, and L star is A star. Guys, I have taken a finite language only, both sides, but its clinic closure need not be finite. Look at that. Some clinic closures, they are inside the same domain, but some clinic closures, they go outside the domain because it is not a finite. This is not a finite, but this is the finite. Right? Sometimes finite, sometimes infinite. Guys, that is the reason it is not closed. Every time no need to go outside. But do you have at least one finite language? Its clinic closure is not a finite? Yes. Yes. So that is the reason it is not closed. When we say not closed, that means you have at least one example in this domain that when you apply the operation on that example, the result goes outside the domain. Yes. Positive closure, same answer. Same examples will work. Subset. Guys, subset of any finite. Tell me, subset of any finite. You take any finite in the world. If you look at every subset, is it a finite or not? Again, yes. Every subset, because it could have many subsets, and every subset of finite set is again finite only. That means result is also inside the domain. That is the reason it is closed. Everybody, subset is closed for finite languages, guys. It is not closed for regulars. In the coming topic, subset is very interesting property. But for the finite languages, this is closed. Clear this point? Yeah. Clinic closure. For that, you need to understand. First, focus on what are you looking at. You have the finite languages. These are not one finite set of finite sets. And here you have epsilon. Here you have even pi. Here, assume sigma is equal to a comma b, let's say. Any sigma you take, doesn't matter to me. A comma b, just a, and a power n, b power n, where n less than 10. I have only finite languages in this domain. Only finite languages in this domain. You should never take as infinite here. And now guys, look at this. If you want to say closed, every finite star must be finite. Is every finite star finite? No, right? No, that's why we don't say closed. Not closed means, is there any? Is some finite? Clinic closure is not finite? Yes. Where is that? Just apply this one. Where is that? This one. If you apply clinic closure to this, the answer is A star. But this is outside the domain, not finite. Inside only finite are there, outside not finite. That's enough. There exists a language inside the domain. After applying the operation, it goes outside the domain. That is the reason clinic closure is not closed. But in case if anybody asks, note, clinic closure of a finite language. You should be very careful. Finite language is dash. Don't say infinite. Here sometimes finite, sometimes infinite. If you look at this one, when you apply the clinic closure, it comes here itself. That means may or may not finite. You should answer like this. May or may not finite. That depends on the language that you take. Clear this point? Clinic closure of finite may or may not be finite. Is the clinic closure, is it closed for finite languages? Not closed. Not closed, need not be finite. Remember these two words. Yeah. Clear that point? Yeah. Let's move on to the infinite languages now, guys. Infinite languages. Now come to the point. We have only infinite languages. What we have in our domain, this is our domain. What is D? We have only infinite languages inside. These are elements now. Every element is infinite language. Every element is infinite language. How many such infinite languages over sigma? Infinite number of infinite languages, guys. Infinite number of infinite languages. Every infinite language over sigma is there inside. Now, what I am applying, first one union. Is it closed? Closed or not? Take any two infinite languages, apply the union. Will you get again infinite? Yes. Yes, so it is closed. Clear? I don't need to show an example. Yes. Infinite intersection infinite. Now we have problem. When somebody is saying infinite intersection infinite, let's say this is I1, I2. Will you get infinite? May or may not. Infinite, guys. How do you know that? How do you know that? For that, you should prove an example. Suppose I take A star. A star intersection A star is A star. I got infinite. But when I take A star intersection B star, both are infinite. But result is just epsilon. Enough. Enough to say that infinite intersection infinite need not be infinite. This example is enough why it is not closed. Everybody, why it is not closed? I found an example. I took two infinite languages. I applied intersection. I got outside the domain element. That is the reason it is not closed. Not closed. But did you get every time outside the domain? No. Sometimes outside the domain, sometimes inside the domain. Okay. Complement of infinite. Complement of infinite, guys. May or may not be infinite. May or may not be infinite. If you take, let's say, I6 is A plus B whole star. इसका complement directly outside रहेगा, क्यों पाई है. Suppose I5 is equal to A plus B whole plus. इसका complement outside रहेगा, क्यों वो finite है, वो finite है. ये तो infinite है. And कुछ ऐसे languages है, if you are doing like starts with A, this I4 complement is also here, that is starts with B or just epsilon. But this is also infinite. The complement I am talking about, complement of infinite, either it could be infinite or it could be finite. That is the reason not closed. Okay, difference. Infinite minus infinite. If you take the same infinite again, you will get empty. That's enough to show that it is not closed. Take the same language. No need to take other language. Concatenation, guys. Infinite dot infinite. हमेशा infinity होंगे. Closed. And infinite language को reversal बना लो. वो reversal ही होंगे. Reversal होंगे, guys. it's a closed. And a clinic closure of infinite हमेशा infinite होंगे, हमेशा. Even positive closure, but subset of infinite. Empty language is subset to everybody. No guarantee you will have always infinite. So sometimes you will also have a finite language as a subset to the infinite set. Remember that. Subset of infinite. Subset of infinite can be anything. Subset of infinite set. You will get either finite or infinite. It depends on your choice. How do you know that? Just take A star. Just take this is A star. And what are the subsets of A star? It can be pi, it can be just A, it can be just A comma double A, or it can be A star itself, or it can be even set, also even number of A's, and sometimes finite, sometimes infinite, right? Every subset you cannot guarantee infinite, sometimes finite, sometimes infinite. So subset of the infinite language may or may not be finite. Is that clear? So that is the reason it is not closed. That is not closed, guys. Okay, positive closure is same as clean closure. Just power 0 is the difference, guys. Okay, so this is about closure properties for infinite languages. Now let's move on to. Okay, before going to the regular languages, let me explain again, guys. The plus more benefits, as I said, that those people who are serious in preparing exam, and the time is the most important factor for you. The time, if you are assuming that we are teaching freely, completely, you can learn everything freely, but that free classes always dangerous. You need to have the self motivation. You need to have the live interaction with an educator. You need to have a discussion with an educator to clear your doubts. But these classes are to deliver the right content in front of you, who can learn. For those people, you can absolutely succeed. You can succeed in the exam. But those people who are not able to motivate, who are not able to follow, who are not able to understand when you are receiving one direction, we are delivering here, or you are not actually asking the doubts here. So when you are listening one direction, obviously there is another problem. Are you able to interpret properly? Is it clear? If this content you want to watch, in the world, hundreds of lectures are there for the same content. But what we are delivering here, we are delivering exactly related to the gate and how much content is needed, which direction you can understand. We know it. We are teaching in the same direction, but still you are lacking something that is an interaction, and you are lacking something that is a practice. And if you are really interested for that, don't waste your time. And plus is going to give you beneficial and live classes, crash courses, and many kinds of courses are there. We are going to help you how to prepare, right? Minimum thing is the plus subscription. If you want to get, definitely money is not the problem to you. Iconic is the more beneficial for you, and you will have a coach to plan and to guide you all the time. You will have booster sessions, you will have analysis of every test and separate study material, guys. Okay, and you can follow me anytime on unacademy.com/@devagatesc. Okay, now let's start closure properties for regular languages. Closure properties for regular languages. And guys, so far actually this is our topic, but did I discuss that? No. Look at the difference between what I teach, what other people discuss about the topic, right? When you know the content right way to present, then definitely will enjoy learning it. So what I'm trying to help you, how can you understand this closure properties for regular? Actually our topic is for regulars, but I didn't start that. I'm trying to help you first. What is closed, what is not closed, I explained it clearly. And then have you understood for finite languages? Have you understood for infinite sets? Then I'm actually moving to the required one. For regular sets, can you understand now? And for this, I've explained the previous few topics, guys. Now union, why is it is closed for regular languages? Why it is closed? The reason is, if you are asking regular 1 union regular 2 is always regular. Why? Do you have any algorithm? Yes. How? You can write, you can design FA1 and you can design FA2. You can do the composition. This composition machine will accept this regular. Or you can write regular expressions, 2 regular expressions. you can do the plus, you can apply the plus in between, so you will get a new regular expression to perform the union. Similarly, there are n number of algorithms, guys. Okay, so it is closed. An intersection, same algorithm, closed. And complement, you know, if I ask regular complement, how can you guarantee that it is always regular, guys? Because I can design a DFA for this, and I can interchange finals and non-finals. Then you will get a new DFA that will definitely accept complement of a regular, guys. Complement of regular. This is an algorithm. So that is a complement of a regular, हमेशा regular है, हमेशा. Everybody, and these algorithms are very important for understanding. And difference, is it closed or not closed? Closed. How can you say that it is closed? How can you say it is closed? Do you have any algorithm to say it is closed? Closed means you should show an algorithm, guys. Regular minus regular. How can you guarantee it is regular? Because you know L1 minus L2. We have a concept. L1 minus L2. Anybody, guys? It is L1 intersection L2 complement. And regular complement, just now we understood it is closed, so you will get again regular. So regular one intersection regular has to be regular because intersection already closed. Intersection complement are closed, so difference is closed, guys. And concatenation, regular 1 dot regular 2. And you can design something like, you can write regular expression here, 1, you can write a regular expression here, and in between these two regular expressions, just to keep the dot, this will be new regular expression that has exactly concatenation. Everybody, yes, it is also closed. It is also closed, guys. And that are the proofs. If anybody want to talk about, you must talk about why it is closed. And reversal, yes, if you want to say regular, reversal of a regular is again regular. How can you prove that? How can you prove that? You can prove using expression, or you can prove using motion, guys. So if you have something like a plus b whole star, iska reversal, just write in the reverse direction, guys. Star and you know b plus a. That's all. This is a reversal. It's obviously same. If you have a b whole star, you need to write reversal. Star and b a. That's a reversal, guys. So reversal of regular, हमेशा regular ही होंगे. You can also show with a finite automata, guys. You can also show with the finite automata. And the clinic closure is closed because just put a clinic star over the given regular expression. And positive closure is closed. Subset is not closed. Why subset is not closed? Why subset is not closed, guys? Why subset is not closed? That is Shubhasri. Suppose you have L is equal to ABC. How to show that is extra job that you have to do. ABC, is it really important for GATE? Not at all. But if you want to remember that, one proof is enough. This is, let's say, design a machine. Either NFA or DFA, it is your choice. NFA or DFA. What do you do here? First, guarantee. Initial state is always final. First, note, if you have many finals, make one final. If you have many finals, first make one final. How do you do that? Make one final. Can you do that first? Can you do that? How do you do that? If there are two finals in the machine, you just create one final, give epsilon transition, and these two make as a non-final. Just make a non-final, guys. Is it clear? You can always make one final, but using epsilon moves, using non-deterministic motion only. Deterministic motion, you can't do that. So you can do that. What do you do now? Initial, make it as final, convert initial as a final, and final as initial, and reverse every transition, reverse every edge. Yes, Gaurav, that is true. Clear that point? Yeah. So now initial, that is A is the final, and final is initial now. This is the D, and this is A, and every state is same, and all the transitions must be reversed. If you have a self loop, keep self loop only, but if you have A to B transition, then make B to A, and transition symbols are same, input symbols are same. Now look at that. Did I get L is equal L power reverse, that is equal CBA? This is an algorithm, guys. It is a reversal concept. Clear? Yes, we have an algorithm, but is it required to learn every concept? Not at all, not at all, not at all. Just you should remember for the competitive exam point, closed or not closed. They will ask which of the following is closed, but they will not ask why it is closed. So when you go to the interview, you must ready with this explanation. Right? But for the exam point of view, may not be required, but for the interview point of view, every point that you are learning here, you must know why it is closed, why not closed. Not closed, give a counter example, and closed, you must show an algorithm like interchange initial and final and reverse every edge. That is an algorithm. Any fundamental you give, I will do the same concept, but before that I will make one final, one initial concept, then I can do interchange easily. Okay, now there are certain operations here. Prefix of a regular, prefix also called as init. Prefix of a regular is also a regular language, is also a regular language. And you have a proof also here, you have proof also. And what kind of proof is same thing, L is equal to ABC, guys, and you have a machine, let's say A, B and C. And if you want to understand, let's say prefixes of L, then how do you understand prefixes, guys? Prefix of L, what are the strings you have? Epsilon, A, AB, ABC, and same machine you copy paste, same machine, no change in the machine. Transitions also no change in the transitions too. Now from initial state to final state, entire path you look at. If there are 100 paths which are going to final, reach every path and make every state as a final there. Make every state as a final. Then what is the advantage? You are going to accept every prefix of the given language, or every prefix of every string of the given language. Epsilon, A, AB, ABC, all of them are accepted now. Right? What is the logic? What is the algorithm? Look at every path from initial to final state, and in that path make every state as a final. Is that clear? Make every state as a final from initial state to final state path. From initial state to final state path. Make every state as a final. Make every state as a final. Okay. And I wanted to announce something, guys. Soon I am going to launch a very special course on theory of computation. Just the course will complete just in 10 hours, and it just whole night, 1 night course it is. So if anybody interested, you can attend. I will announce soon and which day I am going to take that course. Within 10 hours, whole theory of computation is going to be completed. So I will launch that course. If anybody is feeling short of time to learn entire subject, please attend that day. But one day continuously 10 hours, it's really hectic for you. But if you want to sacrifice the time, then you will definitely gain your knowledge. So yes, okay, just wait for the time, and whatever the subject that I am delivering it, I will also make you revise very quickly. But just you should believe me that you must learn some things slowly, so you will get the concepts clearly. So you will have a following me. I will also make you revision very quickly, and just wait for the time. I will announce that too. Okay, that's also completely free. It's not paid one. And suffix is also closed. This is closed for regular because I have shown you finite automata for the prefix. That means it is also a regular, right? It is, I am proving it is a regular because we have a finite automata. If L is regular, then prefix of L also regular. Prefix of L also regular. Now guys, now let's focus on suffix. Tell me guys, what are the suffixes of L? right? Every string, that is, you have CB, BC, ABC. Sure, Sandeep, I have a plan, but first let me finish that how many people are attending the TOC. That based on that I will complete other two also. Now suffix of L. Now look at from initial to final path. I'm going to do something. I'm going to make every state as initial. Every state as initial. Just small change. Look at that. A. No change in the motion, guys. No change in the motion. Motion is same, transition is same. Now I'm adding new transitions. From initial to final path, I'm going to make every state as initial. It means every state as initial. What is the meaning of that? From initial state, I can directly jump to B. From initial state, I can directly jump to C. Initial state, I can directly jump to D. That means every state is initial indirectly. Guys, this is how we can make now suffixes. If you want to accept C directly, you can go to capital C state, you can accept the C. If you want BC, you can go to capital B state, you can accept BC. Right? So this is how you can make a suffix a motion in finite automata. So this is also closed because I have shown you finite automata. And you can convert to DFA, you can convert to expression because we have algorithms. You have an algorithms, guys. Clear this point? Suffix of a regular is also a regular. And remember, suffix of a string is different. Suffix of a language is different. Here we are talking about a language, even though I have taken one string in the language. Okay, now substring. It is also closed. It is also closed. But now, from initial to final state, then I am going to make every state as initial and every state as a final. Both combinations, guys. Initial and final. That means I'm going to make this is also final. All are final, all are initial indirectly. So that I will add the substrings to this language. Now, did you get every substring or not? Check it. Substring of L. Did you get or not? Epsilon, A, B, C, one length, A, B, B, C, and then A, B, C. Did you get all the strings or not? And if you want epsilon, you can stop at A. If you want A, you can accept A and you can stop at B. Similarly, A, B, B, C, everything is possible if you make every state as initial and final from initial to final path. Clear? You have algorithms. If for the exam point of view, they don't ask this algorithm. They ask, is it closed or not closed? Right? Yes, it is. It is, guys. Okay? It is closed. All are closed. Okay, now quotient operation. Is it closed? Yes, this is the one of the important operation for master level. And if you want to understand what is quotient, you can try. You can try like this. If you have A, instead of that, let me apply the definition. If you have UV by V, you will get U. But if you have L1 by L2, this is the right quotient called as. It's nothing but X such that you have XY in L1 and Y in L2. Y in L2. Then you can write every X as a result. Example, if L1 have as epsilon, let's say something easy to understand. Okay, L1 has, let's say, A comma AB, and L2 has something, epsilon B. That's all I have. Then what do? You have to do something. A by epsilon, A by B, then you should have AB by epsilon and AB by B. Every string of L1 must apply quotient with every string of L2, right? L1 and L2 both are two regular languages given. Now apply the definition of UV by V and epsilon. You can see here, if you want epsilon, you can write A is the answer and B is not present here. So this gives nothing, right? But this gives A, guys, and this one gives AB because you can assume epsilon is there here and B is matching. So this gives A. So result is A comma AB, A comma AB, guys. A comma AB. A came twice, so answer is A comma AB. So to understand, this is one of the important operation. So I will try to discuss more about quotient operation. We know it's closed for regulars. Now let me talk about L1 is equal to A star, L2 is equal to B star. If anybody asks L1 by L2 or L2 by L1, how to answer it? And both are infinite languages, so you must be careful. It's just like A star by B star. And A star, guys, you have epsilon, A, double A, triple A. And you should think about everybody. B star also, so many things are there. Then I'm trying to apply, like, epsilon by B star, A by B star, and double A by B star. And if you look at here, epsilon by epsilon, you get a meaning, remaining all nothing. And here A by epsilon, you get a meaning, remaining all or nothing, because you will have a B there. And double A by epsilon, you have a meaning, but remaining have no meaning. Right? So here epsilon, A, double A, and remaining strings, only that you get is A star total. But B has no meaning here. Everybody, guys, A star by epsilon, you can look at that. A star. And if you are applying for L2 by L1, there's a B star by A star. And you can think about it. B star by epsilon, you get a meaning. B star by A, B star by double A, you don't get a meaning at all. These are nothing. So B star by epsilon is a B star is an answer, guys. Okay. So this is all you can understand by practicing quotient operation clearly. What is quotient? It's basically I am explaining about right quotient. If anybody want left quotient, you can understand yourself. By default, quotient is talking about the right quotient. Now substitution is also closed. And homomorphism, inverse homomorphism, all are closed, guys. But if anybody talking about a subset, substitution I will talk about. This is not closed. Have you seen subset of infinite language? Similarly, subset of regular, I can show you there are non-regulars. Right? Now first let me talk about substitution. Substitution. What is this substitution? And substitution and homomorphism almost they are same. Only by definition you have to understand how do they map. Here substitution is also function, homomorphism also function. Here also sigma maps to somebody. Here also sigma maps to somebody. But here every symbol of the sigma map to some language here. Power set of delta star. Here this is a set of languages. This is a set of symbols. So every symbol of given regular, every symbol of given regular language, given regular language is mapped with some symbol, some regular, with some regular language. That regular language is there in the power set of delta star. But regular language is over delta and every symbol of sigma. Every symbol of sigma. Remember that. Every symbol of given regular language, this is over sigma. Okay, that is about substitution. And homomorphism is just delta star. Here every symbol of given regular, guys theory बहुत difficult है, ऐसे पढ़ना समझ नहीं आता. So you need an example. Over sigma is mapped with some string. That's why this is called as set of strings. This is called as set of strings because we are looking at the strings now. Is mapped with some string over delta. Now let's look at an example to understand. First let's look at f. How you map? You are giving input is L. Let's say L is 0 star 1. And here sigma is, remember 0 comma 1. Okay, 0 1 0 let's take. And here you need to map f of 0 with some language. Let's say A star. F of 1 with some language. Let's say AB whole star. AB star let's say. And this is f of 0, f of 1. And what is f? F is trying to map 0 with A star and 1 with AB star. And this is your sigma. This is your power set of delta star. 2 power delta star, guys. What is delta here? Delta is a comma b. Delta and sigma may be same, may be different. That depends on your concept. And what is f of l? It's a mapping of a language. Is also regular. I am showing it. But what kind of regular it is? Look at that. 0. It's nothing but f of 0 star 1 0. It means f of 0 whole star and dot f of 1 dot f of 0. We are going to apply mapping on every symbol. F of 0 already you know, a star whole star. F of 1 already you know because it's given to you, and f of 0 is a star. And this is your answer, guys. Of course you can write further by simplifying it, but this is also regular. This is also regular. And how could be different from homomorphism? Homomorphism is similar to this, but what do you have here? 0 star 1 0. Fine. How this is different from homomorphism? Homomorphism is going to be applied similarly. H of 0, we will have a string there. We will have a string there, guys. String only, not a language. Previously, this was a language. This was which language? Regular language. Now this is a string. It means that 0 mapped with a string and 1 mapped with something like, triple B, let's say. This is also a string, triple B. And here this is called as your sigma. This is called as your delta star because you have the strings here. In this domain, codomain, you have the strings. Okay, if you are applying homomorphism on a regular language, you will get again regular, but this time h of 0 whole star h of 1 dot h of 0. H of 0 is AB. So you will get AB star, 1 is triple B and 0 again AB. So this is your language. It's also regular. It's also regular. Similarly, inverse homomorphism, if you are interested, you can learn or you can catch my special classes on Unacademy. I've already taken n number of classes on these closure properties. Okay, you can learn from there. And now I'm just talking about the subset operation. Subset, guys, you look at this, L is regular, right? A, B holds, simple language, let me take. A plus B whole star, is it regular or not? It is regular. But can you guarantee every subset of this A plus B whole star regular? Can you guarantee every subset of regular is regular? No. That is the reason we got not closed. Example, in this L, if I write a subsets, write subsets of L, sometimes you get A star, that's regular. Sometimes you get B star, that is regular. Sometimes you get A star, B star, that is regular. Sometimes you also get A power and B power n. This is definitely subset of given L, no doubt. But it is not regular, guys. It is not regular. Sometimes regular, sometimes not regular. That is the reason this subset operation is not closed for regular languages. Clear this point? Yes. Clear this point? Yeah. And now the most important factor. There are so many closure properties, but still based on this crash course, I'm not actually going into every detail, but you might be understood the concept already. Closure properties for, now let's talk about non-regular language. Sorry guys, it is for non-regular language. I'm writing here, this is non-regular. This right here, non-regular languages. Okay. Now what is non-regular? It's a very, very difficult concept. Maybe you don't find in textbooks. Okay, but in the GATE questions you may find it. In this domain, I don't have a regular. I have only non-regulars only. Non-regular 1, non-regular 2 and non-regular 3. Only non-regulars. Whichever the non-regular language you know, you can keep here. Here like this, you have infinite number of non-regulars. Outside this domain, regular languages are there. Now, union of two non-regulars. Non-regular, union, non-regular. No guarantee, guys. It is not closed. Why not closed? And most people they confuse it. The reason is, look at that a power n, b power n. Is it non-regular? Yes. Union with उसका complement guys, वो भी non-regular ही होंगे ना? क्या अगर ये regular होगा तो वो भी regular होना चाहिए? Because you know, if L is regular, L complement is regular. अगर L complement regular होगा तो L regular होना चाहिए, right? So this is both are non-regular. Union में आपको sigma star आएगी, पर sigma star तो regular है, वो डोमेन के अंदर नहीं है, right? So you have taken two non-regulars from the same domain, but result going outside the domain. So that is the reason it is not closed. But sometimes you may get non-regular. That doesn't mean that closed. Remember that. Okay, this is why the non-regular union non-regular is need not be non-regular. Answer is like this, guys. Non-regular in general, union non-regular. The result may or may not be non-regular again. Don't say always regular. Remember, may or may not be non-regular. This is the first concept. First concept. Similarly, guys. Similarly, intersection, guys. Non-regular, intersection, non-regular. Will you get always non-regular? No, right? If you get always non-regular, then I can say it is closed. But I'm writing not closed. Do you have any example that non-regular, intersection, non-regular is possible to be regular? Look at that. A power n, b power n. ये तो नॉन रेगुलर है, सबको पता है दुनिया में. इंटरसेक्शन, अगर मैं b पावर के a पावर के लिया तो ये भी नॉन रेगुलर है, पर इसका इंटरसेक्शन सिर्फ एप्सिलॉन ही आएगा. क्यों? पावर 0 में एप्सिलॉन कॉमन है, रिमेनिंग ऑल डिफरेंट. बट ये तो रेगुलर बन गए गाइस, है ना? तो इसलिए द इंटरसेक्शन आल्सो नॉट क्लोज्ड. इंटरसेक्शन आल्सो नॉट क्लोज्ड. पाई नहीं बोलना चाहिए. n इज इक्वल 0 में, k इज इक्वल 0 में एप्सिलॉन कॉमन दिख रहा है, कॉमन दिख रहा है. एप्सिलॉन इज देयर, सो प्लीज डोंट डू द मिस्टेक. कम ऑन शुभश्री, द रिजल्ट इज एप्सिलॉन. फाइन. नेक्स्ट कॉम्प्लीमेंट गाइस. कॉम्प्लीमेंट. कॉम्प्लीमेंट, इज इट क्लोज्ड और नॉट क्लोज्ड? गाइस आपको पता ही है दैट L इज रेगुलर, L कॉम्प्लीमेंट हैज टू बी रेगुलर. अगर L कॉम्प्लीमेंट रेगुलर हो तो L रेगुलर होना चाहिए. दिस इनडायरेक्टली सेज दैट अगर L नॉन रेगुलर हो उसका कॉम्प्लीमेंट भी नॉन रेगुलर ही होना चाहिए. अगर रेगुलर होगा तो L भी रेगुलर होना चाहिए, राइट? सो दिस इज क्लोज्ड प्रॉपर्टी गाइस. नॉन रेगुलर कॉम्प्लीमेंट हमेशा नॉन रेगुलर है. अगर कोई भी रेगुलर दिखाया तो उसकी कॉम्प्लीमेंट भी रेगुलर होना चाहिए, है ना? तो दिस इज बोथ स्टेटमेंट्स आर सेम. L is regular if and only if L complement is regular. Internally we are speaking L is non-regular if and only if L complement is non-regular. Remember. And difference L1 minus L2 not closed. ऐसे कुछ जल्दी एग्जाम्पल दे सकते हैं आप? Difference जल्दी एग्जाम्पल दे सकते हैं which is not closed. Same example guys. अगर A power n B power n लिया ना, ये नॉन रेगुलर है, और माइनस सेम लैंग्वेज ले लो, नॉन रेगुलर. पाई बनेगा ना, अभी पाई बनेगा. ये तो रेगुलर है, ये तो रेगुलर है. तो बहुत इजी एग्जांपल है. व्हाई नॉट क्लोज्ड? कंकैटिनेशन नॉन रेगुलर डॉट नॉन रेगुलर. गाइस नॉन रेगुलर ही आएगा. देख लेते क्या है, आएगा क्या? मुझे भी मालूम नहीं, मैं चेक करना ही पड़ेगा गाइस. नॉन रेगुलर डॉट नॉन रेगुलर. कभी कभी मैं गलत भी बोलता हूँ, क्यों? नया नया डिफाइन करता हूँ हमेशा. तो नॉन रेगुलर डॉट, ये बहुत डिफिकल्ट वाले हैं. मैक्सिमम 99% दिखता है नॉन रेगुलर है. ऐसे कुछ एग्जाम्पल है दुनिया में, देयर एग्जिस्ट ऐसे कुछ एग्जाम्पल है रेगुलर आने के लिए चांस है, लेना पड़ेगा गाइस. ये a पावर n b पावर n ले लो और उसकी कॉम्प्लीमेंट लिया और उसके साथ एक एप्सिलॉन ऐड कर लिया, बस एप्सिलॉन ऐड कर लिया गाइस. अब तो पूरा a प्लस बी होल स्टार आएगी पक्का, कि इसके अंदर एप्सिलॉन ऑलरेडी है ना? तो रेगुलर आने के लिए चांस है गाइस, है ना? तो हर स्ट्रिंग आएगा दुनिया में. ये बहुत कम लोग पता है, मुझे भी कम पता है गाइस, कभी कभी मैं भी गलत बोलता हूँ. a पावर n b पावर n ये एक लैंग्वेज है डॉट, एक लैंग्वेज ऐसे वाली है a पावर n b पावर n, इसकी कॉम्प्लीमेंट यूनियन एप्सिलॉन लिया. ये क्या प्रोड्यूस करता? ये पावर n b पावर n आएगा, इसकी कॉम्प्लीमेंट भी आएगा यहाँ पर, है ना गाइस? तो यूनियन a प्लस बी होल स्टार बनता. दोनों अगर आपके साथ है L and L complement, O union A plus B होता रहेगा. If you want this one, then put epsilon. If you want this one, यहाँ पर epsilon भी है अंदर power 0. Everybody, so we have two options here. So this is very interesting one, guys. Concatenation of two non-regulars, no need to be non-regular again. So it's also not closed. But 99% ऐसे दिखता है non-regular ही है. But 1% सोचना ही पड़ेगा वो regular आएगी क्या. Reversal of non-regular हमेशा non-regular, guys. हमेशा. ये closed है. ये closed है, guys. Look at that. Reversal is closed. Complement is closed. अब तक. Clinic closure of a non-regular. आपको चेक करना ही पड़ेगा. Non-regular clinic closure a non-regular बनेगा. ये previous gate question है, guys. ये clinic closure of non-regular. Come on, try that, guys. Yeah. Please discuss with that. Clinic closure of non-regular. ऐसे कुछ दुनिया में non-regular है, उसका clinic closure regular आ रहा है. Best example previous gate में आया. A power prime तो non-regular है, guys. ये तो non-regular है, सबको पता है दुनिया में. इसका clinic closure है, ये तो regular आता, guys. Regular है. So there is no guarantee of non-regular. Because of this example, this both are not closed, guys. Clinic closure of non-regular, no need to be non-regular again. It may be regular, it may be non-regular. And subset of non-regular, it could be possible to be regular. Because A power n B power n के अंदर, A power n B power n के अंदर आपको पाई भी है ना, सिंगल स्ट्रिंग भी है, एप्सिलॉन भी है. ये सारे क्या है? ये रेगुलर सी है. ये सारे सबसेट से, गाइस, है ना. बट इटसेल्फ इज आल्सो देयर, है ना. ये तो रेगुलर ही है. एंड सबसेट ऑफ नॉन रेगुलर कुछ भी हो सकता दुनिया में. रेगुलर भी हो सकता, नॉन रेगुलर भी हो सकता. समटाइम्स रेगुलर, समटाइम्स नॉन रेगुलर. इसलिए ए बी नॉट क्लोज्ड है, गाइस, है ना. प्लीज ट्राई टू रिमेंबर दिस. इफ यू कांट अंडरस्टैंड द प्रूफ्स व्हाई दे आर नॉट क्लोज्ड, definitely this might help you somewhere, guys. And these are the important operations that I have discussed today. Closure properties for regular languages. अगर आपको कोई भी ऑपरेशन ऐसे यहाँ पर है, उसका एक प्रूफ चाहिए, जरूर आप please attend the already have taken so many classes on the closure properties. You can visit my profile anytime, guys. Right, you know that @devagate/@devagate_CSE. Unacademy.com, www.unacademy.com. Please visit this profile and you will get every link. As I was talking about simply closure properties, I have nearly 5 classes, and if you want to practice, you want to learn everything in detail, you can go and attend free classes, right? So we have today learned what are the closure properties, which are closed, not closed for finite and infinite, regular and non-regulars. Right. In future, we are going to talk about more interesting properties of the closure properties of regular languages, like decision properties, and so many other properties are there. And this is my profile link. Please visit and know and learn many concepts from me, and I will keep on discussing that. Okay, this is our group, computer science group on Telegram, and this channel you can subscribe, because from our educators group we are posting every day class links so that you will get benefited from our classes. And also we share our material sometimes here. You can download and you can study, and these are all free YouTube channels from us for various engineering students. If you have any friends from electronics, electrical, instrumentation and mechanical, civil and any other, they are preparing for SSC or RRB and gate questions you wanted, and please follow this YouTube channels and share with your friends, and they will also start learning from us. And thank you so much, and please don't forget to like the session, and please do this and also share and also subscribe, and do not forget my referral code. DEVALIVE is my referral code. In case if you want to take the subscription on Unacademy, this is going to help you to crack the GATE exam, and I'm always there to help you. And this DEVALIVE is not for my courses, guys, it is for Unacademy subscription. And if you once take a subscription using any educator referral code, and inside everything is free, remember that. Okay, you will have a test series, you will have you can attend any live session from any educator, but this referral code will help you. Will also get a guidance from me how to prepare for GATE. Okay, and tomorrow and day after tomorrow we have very interesting sessions. Please don't miss tomorrow and day after tomorrow. Tomorrow and day after tomorrow we have special classes, then how to prepare in 60 days, how to stay motivated, and so many points I'm going to cover from tomorrow onwards. For next 2 days we will have special sessions, and please stay tuned with this channel, and see you tomorrow guys. Thank you so much for joining today's session. See